big Star Wars fans in here? No? Kind of, yeah. Yeah, it's May the 4th be with you. I could have worn a Star Wars shirt. I would have had to steal it from my daughter, but I didn't think about that. I would have definitely worn a Star Wars shirt. All right, so looking at, we'll start with 6 since we should go in numerical order here. The directions want you to write these series in sigma notation, which is that short way with that sigma, the Greek letter. It kind of looks like an E. And in number 6, we have 5, 10, 20, 40, 20,480. So when you're writing a sequence in sigma notation, we do still need to think about our series. We need to think about, is it arithmetic or geometric? And the reason you have to decide that is because we also have to find out how many terms are in the series. So when you write sigma notation, the number on top represents how many terms are in the series. So we have to figure that out. We also have to figure out the formula, which is why we need to know if it's arithmetic or geometric. So we can figure out that formula and then we can figure out the number of terms. So to go from 5 to 10 to 20 to 40, what are you doing to get from one number to the next? Ava? Yeah, and if you're multiplying by 2, that means it is geometric. So it's geometric, we're multiplying by 2. Now, it's the explicit formula that we need to write next to the sigma, because the explicit formula represents the formula where you can just plug in a 1, a 2, a 3. You don't need to use the previous term. When it's geometric, we have the first term, if I get it right, times r to the n minus 1. So the first term is 5. Ava said r is 2, and then you have n minus 1. So the formula part is right here, and that's going to go next to the sigma. So 5 times 2, n minus 1. That would be our geometric formula. So you can see what we did with sequences, we're still using and applying to series. Now we need to figure out the number of terms. On the bottom, we're going to start with n equals 1. And I'll show you an example or two today where that's going to change when we create our own formula. How would you find the number of terms of this series? So what would we do to find the number of terms? We have a formula here equal to a sub n. Jaden? Yeah, so you're taking the last term, which is a sub n. That really represents any number, any term in the sequence. Well, we're trying to find the last term, so we're going to use the last term. And then 5 times 2 to the n minus 1. The n represents the position of that term. What number of the sequence is it? So to solve this, we would divide first by 5. And Jaden, do you have 2048 divided by 5?
Yeah, I got 4,096.
So divide by 5 first to get rid of the 5. You cannot multiply those two numbers together because a 5 is an integer and the 2 is attached to the exponent. It's an exponential value. So divide by 5. And then to solve this, you have an exponent of 2 to the n minus 1. So we're going to change that into log form. So log base 2 of 4096 equals n minus 1. Remember, in math, when you learn something, the goal in math is to continue to use it and find other ways to apply those concepts. It's a wonderful thing about math. So Jaden, log base 2 of 4096 is?
That is 12.
So n is 13. So that means 2048 is the 13th term. But since it's the last term, there are 13 terms in our series. So n equals 1 represents, I would plug a 1 in to find the 5. 13 represents, I'd plug a 13 in for n to find the last term of 20,480. Questions? So sigma notation is just another way that we can write a sequence or a series instead of writing it in expanded form. So we're going to go underneath and look at number 8. Now, number 8 used k instead of n. And the variable can change, just like it doesn't always have to be an x in an equation. We could have an n in an equation, an m in the equation, a z. So we know that variables can change. And in sequences and series, the variable can change as well. So looking at 8, the directions wanted you to evaluate, which means I need to find the sum of the numbers in this series. That's what sigma represents. The sum of the series. We have 1/2 to the power of k, but then this one's a little different. Brooke, what do you notice about this one here, the sigma notation? What's on the bottom underneath the sigma? The k is 2, not 1. So that tells you that you're starting by plugging in the number 2. So you're not plugging in a 1 because it doesn't say k equals 1. So that value down there is the number that you start with. That's the number you plug in first. So we're plugging in a k equals 2 first. So I would have 1/2 squared. When you square a fraction, square the top. Well, 1 squared is just 1. Square the bottom. 2 squared is 4. So 1/2 squared is 1/4. And then I cube it and I get an 8. And then I have 1/16. Cheat here. So 5, 6, 7. So you keep taking 1/2 to the next exponent. So 1/2 to the 5th is 1/32. 1/2 to the 6th is 1/64. And then 1/2 to the 7th power is 1/128. So really, you're taking that denominator and applying the exponent. You're raising it to that power. So you're squaring 2, you're cubing 2, you're taking 2 to the 4th, 2 to the 5th, 2 to the 6th, 2 to the 7th. Questions with those values? Please give me exact values. So a fraction of 1/2, squaring it, cubing it, you get nice fractions. You should be able to kind of work through those.
Okay, so when it says like 7 on the top, almost like the number of terms, so would that mean that like you go to the 7th power? Does that mean you have to have 7 values?
It means that you would stop at plugging in the number 7.
Okay.
So you may have 7 values if this started with a 1 on the bottom.
Okay.
So the number of values you would have would start with 2 and go to 7, so you'd have 6 there. So that's a good question. So the number on top represents the last number that you should plug in. 8. So this actually, good question, because I didn't list that. That's actually A2, because you plugged in a 2, so that means you're really finding the second term. We're skipping over the first one. It doesn't matter in this case. It's not part of the series. So then I would have my 3rd, 4th, 5th, 6th, and 7th. So the number you plug in always represents your term. In this case, we just skipped the first one. It's not part of the series. Good questions. When you add all these together, the denominator I know is 128, because that would be the common denominator. Is it 64? 63? Ah, there's one off. 63 over 128. So that's the last part. To find the, or evaluate this, you still do need to find the sum. So all of these, because they're being added together, you are finding them the sum of those numbers. So I did say we're going to practice 2 more problems, and one of them is going to be like this here, and then actually one will be like the one above. So we'll practice 2 more of those. And then we're going to start the homework for today. It's just more practicing kind of using this finite series, because tomorrow and Thursday we'll flip it and have the infinite ones where I don't know what the last term is and how does that change the problem. So that's what we'll be working on then the next 2 days. I did say yesterday, this is a short, like, it's really just kind of 2 different topics. It's either a finite series or an infinite series, one or the other. So series are really short, not too much going on with them. So if you want to pull out that chapter 12 notes, what we were working on yesterday, page 18, we're going to practice using sigma notation. So write the series in sigma notation, evaluate the series in sigma notation. So we're just going to practice 2 more of these problems. And a series and a sequence are almost identical. I still have arithmetic and geometric. Except a series, you're adding all of the numbers together, whereas sequence is a list of numbers. That's the only difference, a list versus things being added together. So when you look at a problem, when you look at a series or a sequence, that first question should still be, is it arithmetic or geometric? That's how you should start. So what are we working with here? Are we working with an arithmetic series, a geometric series? Gabby Soul, what are we looking at here? Arithmetic or geometric? Yeah. And that D value, to get from one number to the next, what are you doing, Gabby? Subtracting 3. So this one says write it in sigma notation. So we're going to have that E. We're going to find the number of terms on the top, and we're going to write the formula next to it. So let's start by getting that formula to write next to it, and then we can find the number of terms using the formula. So Gabby said arithmetic. And when it's arithmetic, you start with the first term. The n minus 1 is a quantity being multiplied by the difference of -3. And again, that's being multiplied. The addition sign is separating the first term from the quantity n minus 1. So we have 10, distribute the 3, -3n plus 3. So that formula, you could say 13 minus 3n, or you could say -3n plus 13. However you choose to write it. That's my formula next to the sigma, 13 minus 3n. And you'll see parentheses around that. Doesn't necessarily have to be parentheses around it. That sigma is kind of including both of those terms. So Jordan, how would you find then the number of terms? Yeah. So a sub n is -53. So then if I subtract 13, how many terms are there, Jordan? 22. So our number on top is a 22. And then you have sigma notation. So both of those things we've done, we just did them separately. So with a sequence, you found the equation, you found the formula, or you found the number of terms in a separate problem. Now we're combining them together in one problem to create this series. So looking at number 6, you can see number 6 is similar to the sigma notation that we just went over from the homework, where it's not starting at 1. And instead it's starting with the third term of the series. So it doesn't always start with the first term of the series. So just kind of look at the bottom. That's the number you start plugging in. The top, if it doesn't start with 1, then there aren't going to be 8 total terms, but I still plug in an 8 to find the last term. So this is really starting at the third term, and you're plugging in a 3. In both places for n. So there's 2 n's here. In both of those positions, you're plugging a 3. And then you would plug a 4. And then a 5, and then a 6, and so on, all the way to 8. So I kind of cheated. I wrote a shell and then copied my shell and repeated. So I just plugged in my missing numbers. So let's think about this. When you have a -1 and you cube it, what is -1 cubed? -1. And then you multiply that by 6 and you get -6. When you take -1 to the 4th, the number is a +1. So +1 times 8. And then -1 to the 5th goes back to being negative. So now it's -10. When I raise it to the 6th, it's positive again. So +12. The 7th is negative. And then raising it to the 8th power is positive. So remember, an odd power, you have a negative. Any value to an odd power, if it's negative, it's going to be made negative. Any negative number to an even power will become positive. And then you add all those numbers together. Don't forget that part, because that's what the sigma represents. It's the sum of the series. This really is a series. If I wrote this out, I'd have -6 plus 8 plus -10 plus 12 plus -14 plus 16. It still is a series. It's just written in a short form. So when you add all these together, what do you get? Riley, do you have the number? 6. Questions? I think it should be bigger, but because the numbers are negative, positive, negative, positive, kind of adding and then subtracting, adding and subtracting a little more. Any questions? So I said I wanted to start today's homework with you and then give you time to just work on these series and practice them. So we'll go right to Google Classroom and get this homework started. I want to do 2 problems with you that are in this sigma notation, but we're going to try and write the series in sigma notation. So that's where I want to start, so that we can try and write a series in sigma notation that might not start at 1. And I want you to see why or how you can write your own series that doesn't always have to start with a 1 on the bottom. At the top, it should say more practice finite series. So the first group of problems, first ask you to determine if it's arithmetic, geometric, or neither. And then it says, find the sum of the series. Just as a little refresher, let's write at the top what the formula is for the sum. So yesterday, what did we say the sum of the arithmetic series was? How could I find the sum of the series? What was the formula? So we did that pile of reeds problem. Ava? Yeah. So you're adding the first and the last pair together. You're multiplying that by the number of terms, but then because you're adding the pairs together, you're cutting that in half. So the number of terms times the sum of the first and the last term divided by 2. So that's when it's arithmetic. Ava, do you remember when it's geometric? Yeah, 1 minus r. So the question says, determine if it's arithmetic, geometric, or neither. Well, we have formulas for arithmetic and geometric, but there isn't a formula when it's neither. So you would just have to literally add all the terms of the sequence together. So if you say one of these are not arithmetic or geometric, you can't use a formula if it's not one of those. So then you're just going to have to add the numbers together. That's the only way to find the sum when it's not arithmetic or geometric. If you can go to number 10 and 11, 12, 13, the last group of problems, which should be on the second slide. Number 10, the directions for this group say write each series in sigma notation. And of course it says show all work. So if you look at 10, we have 4 cubed, 5 cubed, 6 cubed, 7 cubed, all the way up to 12 cubed. If I'm cubing each number, 4 cubed is really 64, 5 cubed is 125, 6 cubed is 216. Are you adding or subtracting the same number? Are you multiplying or dividing the same number? No, because you're cubing these numbers. So this would be a series that isn't arithmetic and it's not geometric. But we can still write it in sigma notation because it still has a pattern. It still has a formula. So let's start with the formula. That would go right next to the sigma. This is neither, however you prefer to say that word. Neither, neither. What would the formula be for this sequence if I had 4 cubed, 5 cubed, 6 cubed, 7 cubed? Gabby? So she said you could write it as n plus 3 and then cubed. That's one way that you could write the formula. And if you write it like that, your n would start at 1 because I'd plug a 1 in. 1 plus 3 makes 4. And then Gabby, on the top, what would the last value be that you plug in an n for to get to 12? A 9. So that could be one formula and one way to write sigma notation. So she said n plus 3 because 1 plus 3 makes 4. And then you're cubing it. So then if I plug a 2 in, 2 plus 3 is 5, then I'd have 5 cubed. That's one formula. Let's try and write a second one. What if I said you don't have to start with a 1 on the bottom? What other way could you write a pattern for this? If you didn't always have to start with 1. What's the first number of this sequence or series that you're starting with? 4. A 4. So if we started with 4 and ended with 12, how could I write that formula then? Jaden?
Would it just be n cubed?
It would just be n cubed. So if I start with 4, then I have 4 cubed, and then I would have 5 cubed, and then I would have 6 cubed, all the way up to 12 cubed. So you could make it a really easy formula and just say, hey, I'm just taking the number and cubing it, and I'm just going to start my number at 4. That would be a different way that you could write this series. Both of them are correct. Just depends on the number that you decide to start with on the bottom. So when you look at number 11, let's take a peek there. We have 7/5, 7/6, and then it says 1. And then 7/8 all the way up to 7/15. How could you write 1 as a fraction? Alyssa? Yeah, 7/7, just so that my pattern looks kind of alike here. So 7/5, 7/6, 7/7, 7/8, 7/9, 7/10, 7/11, 7/12. Let's write this in sigma notation. Alyssa, do you have an idea how we could write a formula for this? What number is always on the top every single time? 7. So that's going to be on the top. What could you put on the bottom? You could do n plus 1. Let's keep it easy. Let's just say n. Let's make it easy on us. So if my formula, for some reason I wrote that really small. Let's make it a little bigger. Says 7/n. Where would you start and where would you stop? Alyssa, where would you start? And you would stop at 15. So we could write another one. Put a little dotted line down here. 7 is always in the top, but then you could say, well, maybe I want to make it n plus 4. Because 1 plus 4 is 5. So I could then say n equals 1 and start by plugging in a 1 to get to the 5. And then to stop, I would have to stop at the number 11 to get to 15. 11 plus 4 is 15. You can make any equation that you want. Like you could just do n plus 1, and then whatever number plus 1 that makes 5 is where I would start. That's only when it's neither. So if it's not arithmetic, if it's not geometric, then you can kind of start with different values. Thanks. Thank you much. Any questions on that? So ask yourself, is it arithmetic or geometric? And then if you say no, then you'll have to write your own formula and you can start it with a different number on the bottom. Otherwise, it's going to start with a 1 and end with the number of terms. So you have about 10 minutes. You have 2 of those problems done in sigma notation. Feel free to finish the rest or go back to the first group of problems, determine if the series is arithmetic, geometric, neither, find the sum, and then of course it says show some work, and I'll pull up those formulas again. If you